Welcome to this video. In the previous video, we learned the graphical representation of cumulative frequency distribution. In this video today, we will see interesting examples based on it. The per-day profit of 100 shops in a town is recorded as follows. So can you draw less than type of ogive for the above data? Let's see. We know that to get the ogive in the given distribution, we need to create the cumulative frequency distribution for less than type of ogive. Here you can see that 50, 100, 150, 200, 250 and 300 are the upper limits of the corresponding class intervals. To represent the data from the obtained distribution table graphically, mark the upper limits of profit on the x-axis in rupees and cumulative frequencies on the y-axis, where upper limits indicate profit and cumulative frequencies indicate the number of stores. Here, we take a square unit on the x-axis equal to 50 rupees and a square unit on the y-axis equal to 10 shops. Let us now plot the corresponding points A, B, C, D, E and F of ordered pairs obtained from all these upper limits and corresponding cumulative frequency, and join all these points carefully. The curve so obtained is called less than of cumulative frequency curve or ogive. Let's look at another example. In a colony, the heights of 360 trees were measured, which is represented in the following frequency distribution. So can you draw both ogives on the same graph for these figures and then find the median height of the trees? Let's see. With the help of the given distribution, we first construct a less than cumulative frequency distribution for less than type of ogive. Where the corresponding upper limits of the class intervals are from 7 to 56. So can you draw less than type of ogive with the help of the above distribution? Well done! To represent the data obtained from the distribution table graphically, mark the upper limits on the x-axis and cumulative frequencies on the y-axis, where upper limits indicate the height of trees and cumulative frequencies indicate the number of trees. Here, we take one square unit equal to 7 feet on the x-axis and one square unit equal to 50 trees on the y-axis. Let us now plot the corresponding points of ordered pairs A, B, C, D, E, F, G and H obtained from the upper limits and corresponding cumulative frequency and join them carefully. From which we get a curve which is less than type of ogive. So now, can you get more than type of ogive using the given distribution? Perfect! For this, we will need to construct more types of cumulative frequency . where 0 to 49 are the lower limits of the corresponding class intervals. To represent these obtained data graphically, mark the following lower limits on the x-axis and cumulative frequencies on the y-axis. Plot the corresponding points of ordered pairs A, B, C, D, E, F, G and H obtained with the following limit and the corresponding cumulative frequency, and carefully join all these points. From which we get a curve which is called more than type of ogive. Since we have to find the median for this along with both types of ogives, can you guess what we have to do for this? Perfect! For this, we will draw both ogives on the same graph. If you look carefully, you can tell that these two ogives intersect each other at a point. If we draw a perpendicular from this point of intersection on the horizontal, the point at which the perpendicular drawn intersects the x-axis is the median of the data. Thus, 32 is the median of these two ogives. So, we can say that the median height of the trees is equal to 32 feet. We hope that you would have understood the graphical representation of cumulative frequency distribution. Teachers can also test students' understanding in the class with the help of some such examples.